So good morning to all of you. In previous session, we have seen example for finding particular solution or determining particular solution from the given difference equation. We will today discuss one more example to identify the particular solution. Okay. So again, in this example, you have to determine the particular solution for the given difference equation. Okay, it is a second order difference equation, right? Here the input or the forcing function is nothing but again input x of n is given as 2 raised to the power n for n greater than or equals to 0 and 0 elsewhere, right? So again, how to solve this? So again, we will write the given second order difference equation is the given equation, that is y of n is equals to 5 by 6 power of n minus 1 minus 1 by 6 power of n minus 2 plus x of n. Okay, and the given input is, what is the given input? X of n is equals to 2 raised to the power n. Okay, or even because as this condition has been specified, that is it is exists for n greater than or equals to 0 and 0 elsewhere, you can modify this input. This is 2 raised to the power n, you can simply write it 2 raised to the power n into u of n. Okay, because this will exist only for n greater than or equals to 0, as we know that u of n is 1 for n greater than or equals to 0, right? So the particular solution of the given difference equation has the form as yp of n is equals to k into x of n. Okay, so k into what is x of n? So x of n we are considered here, it is 2 raised to power n. It is given in the problem, that is x of n is equals to 2 raised to power n, but as it exists for n is equals to n greater than or equals to 0, we have modified it as 2 raised to power n into u of n. Okay, so this yp of n has the form k into 2 raised to power n u of n. Now we will substitute this value in equation 1. Okay, I will say that substitute yp of n in equation in equation 1. So you will get equation 1 as, so in place of y of n you will substitute k into 2 raised to power n u of n. Okay, so k into 2 raised to power n u of n is equals to, in place of 5 by 6 y of n minus 1, it will be 5 by 6 k into 2 raised to power n minus 1 u of n minus 1. Okay, because there is y of n minus 1. Similarly, it will be minus 1 by 6 k into 2 raised to power n minus 2 y of n minus 2, sorry, u of n minus 2. Okay, because there is y of n minus 2, so it will be u of n minus 2. And there is plus x of n, so it will be plus, in place of x of n you will substitute this value 2 raised to power n u of n, so 2 raised to power n u of n. Okay, so this is what the required particular solution. Okay, the equation after substituting the particular solution in equation 1. Okay, so here you have substituted, in place of y of n you have substituted k into 2 raised to power n u of n. Okay, k into 2 raised to power n u of n is equals to 5 by 6 k into 2 raised to power n minus 1 u of n minus 1 minus 1 by 6 k into 2 raised to power n minus 2 u of n minus 2 plus this value of x of n is 2 raised to power n u of n simply. Right. So again, you have to solve this equation for determining the value of k such that each one of these terms should exist. Okay, so for finding k, substitute value of n greater than or equals to 2. Why greater than or equals to 2? If I am substituting value of n is equals to 1, so it will be u of 1 minus 2. Okay, so it will be u of minus 1, and u of minus 1 is 0, so this term will get vanished. Okay, but to find the value of k, each one of these terms should exist in this equation. None of these terms should get eliminated, or none of the terms should get vanish, right? So therefore you can substitute n greater than or equals to 2, right? So for finding value of k, substitute value of n greater than or equals to 2 in above equation, right? Okay, so what equation you will get now? So k into 2 raised to the power, if I'm substituting n is equals to 2, right? So k into 2 raised to the power 2 u of 2 is equals to 5 by 6 k into 2 raised to the power, what will get, 2 minus 1 u of 2 minus 1 minus 1 by 6 k into 2 raised to the power 2 minus 2 u of 2 minus 2 plus 2 raised to the power 2 u of 2, right? So directly I can write here. So it will be 2 raised to the power 2 will be 4, u of 2 is 1, so it will be 4k, right? 4k is equals to 5 by 6 k into this value 2 raised to the power 1 will be 1, that is 2 raised to the power 1 will be 2, right? So u of 1 will be again 1 minus 1 by 6 k. So again it will be simply 2 raised to the power 0, 2 raised to the power 0 is 1, u of 0 will be again 1. Okay, so it will be 1 by 6k simply, right? So again it will be 2 square u of 2, so it will be 4, right? And u of 2 is 1, right? So simply this is the equation, required equation. Okay, so again I can shift these terms of k on left hand side. Okay, and then I can solve it, right? So it will be simply 4k, so 4k minus, it will be 5 by 3k, right, plus 1 by 6k, right, is equals to 4. Okay, so if you solve this equation, this left hand side, so you will get simply the term that is nothing but 5 by 2, right? If you solve this complete equation, so it will be 12. So again I can simply so again you can simply solve this, that is 4k minus 5 by 3k will be simply 7 by 3k plus 1 by 6k is equals to 4. Again I will solve this, so I will get simply, this is as 45 by 18k is equals to 4, right? So again I can minimize it, so 9 to the 18, 5 is the 45. Okay, so if I, it will be simply 5 by 2k is equals to 4, right? So k is equals to, simply if I set it on the right hand side, that is 5 by 2, so it will be 2 multiplied by 4, that is 8 by 5, right? So the value of k will be 8 by 5, and I have to substitute this 8 by 5 in the given, or in the particular solution to get the final particular solution. So the required particular solution is simply yp of n is equals to k into, okay, so the value of k is 8 by 5, so 8 by 5 into k into 2 raised to the power n u of n. Okay, 8 by 5 2 raised to power n u of n, right? So this is the required particular solution, and this is assumed for what, n greater than or equals to 0, right? As this condition is provided in the example itself, right? So this is the required particular solution. So this is how you are identifying the particular solution, right? So again, the particular solution is assumed as constant into the input. The value is substituted in the given difference equation, and then this equation has been solved to identify the value of k. After finding the value of k is substituted in the particular solution to get this final value of the particular solution. So in next session we'll be discussing how to combine this homogeneous solution and particular solution, okay, that is yh of n plus yp of n to get the complete solution, that is y of n. And by using this solution you can how to identify the zero state response of the system. This will be discussing in the next session. And then after finding this zero state response, and because we are identifying this zero state response by using the combination of homogeneous solution and particular solution, and by using homogeneous solution we have already seen how to identify the zero input response, that is yzi of n, and then to determine the total response of the system, that is y of n, as the combination of zero input response and the zero state response. So these things we'll discuss in the next session. Okay, so thank you for joining this session.